बच्चों, we were discussing the scales in a last session, and there are two things which are important in a scale. One is called representative fraction or scale of factor or scale of factor. This is also known as RF. If you recall my previous lecture where we discussed what is RF, RF is nothing basically length of a line in the drawing to the actual length of the object. And if you look at here on the basis of one was known as the normal or full size scale. The second one was known as the reducing, and the third one known as the enlarging scale. And if you look at here, if the ratio is 1:1, what does it indicate? That actual length of the object is 1 and length of a line in the drawing is 1. This represents full size or normal scale. Whatever the actual measurement which are given to you, we are drawing it on the drawing sheet or on a plain paper by making use of the same dimension. And if it is 1:2, what does it indicate? 1:2 or x is greater than 1. What does it indicate? Your actual length of the object is 2 and you are reducing by half, means 0.5. Or if it is 2, this is 1, means basically the value is 0.1, means this type of scale is known as the reducing. You will find word map. In word map, you will find the application of this one. Country map like India or US or Canada or Australia, whatever it is, country map. Similarly, contingent map, you will find a contingent map. You can draw the separate contingent: Asia, Europe, South America, North America, Africa, so on. And even for the state like Punjab, Haryana, Himachal, you will similarly for your state and for your district, because these are the things which you can't draw on a plain paper, because your drawing sheet, it is having a certain dimension which can't be covered. Even for making of your college or maybe where you the industry where you are serving, you will have to use of this reducing. In the larger scale, what happens? It becomes 2 by 1 maybe. What does it indicate? 2:1, where x is greater than 1. Your actual length is 1 and you are making use of a length of a line in the drawing is 2 times. Means you are, whatever the dimension, you are multiplying by the 2 times. That becomes an enlarging full scale. The small article, maybe this is a chalk, which is having dimension. If you draw it on a drawing sheet, if you are going to draw the dimensions of only of this object, rest of the space will be unutilized. For that, what you can do, you can draw it on enlarging scale. And more or less, this is also known as the zoom category. In computer, if you might have seen, you make use of the zoom category on a positive sign. Similarly, in reducing scale, if you are reading an article or a paper, if it is done on a 100% scale, then this is the normal. And if you are reducing it by 75, means you are reducing the size, and if you are able to read the article, where you will find, if you make use of the computer while reading the article, you will find the application of the normal, full size scale, reducing or enlarging scale. So similarly, we'll have another one that is called the length of the scale. This we have already discussed. Length of the scale. Length of the scale. What is length of the scale? This is RF into maximum distance to be measured. Maximum distance to be measured. To be measured. On the basis of this one, you will make different types of scales. On the basis of this one, you will make a different types of scale. One is called a plane scale, PLAIN. We'll discuss another word. We'll find a plane, PLANE. We'll later on discuss the difference between the plain PLAIN and another is if you spell it PLANE. We'll discuss this the difference between the plane and a plane in a subsequent classes. Here we are discussing only the plane scale. Then the second category is the diagonal scale. This is the type of scale. I'm going to discuss the type of scales. Plane scale, diagonal scale, then comparative scale. Comparative scale. Then the fourth category is vernier scale. Vernier scale. And the fifth category is isometric scale. Isometric. And the sixth category is scale of chord. Scale of chord. I will discuss one by one. Where if you are measuring the dimension up to 2 dimension, maybe meter, decimeter. If you read it here, you are going to measure up to 2 dimension, meter, decimeter. Let us assume 6 meter, 5 decimeter. Or I say 5 decimeter, 4 centimeter. Here there are two units involved, meter, decimeter, here decimeter, centimeter. And 4 centimeter, 3 millimeter. Again there are 2 dimensions involved. You will make use of the plane scale. And when there are 3 dimensions involved, as the word indicates, diagonal, means as the word indicates, if you look at this object, this is the rectangular object, if you join it with this is the point A, B, C, D, if you join C with A, this becomes the diagonal. This becomes the diagonal. So similarly, we'll make use of these diagonal concept while drawing on a when we will take this diagonal scale separately, we'll discuss in deliberation or we'll discuss in detail on that one. What is the importance of diagonal scale? You are going to measure the dimension up to 3 dimensions, meter, decimeter, and centimeter. Meter, decimeter, and centimeter. And or you can measure it like this one, decimeter, centimeter, millimeter. Here again there are 3 dimensions involved, decimeter, centimeter, millimeter. So similarly kilometer, hectometer, decameter. If I am talking kilometer, hectometer, decameter. Again there are 3 dimensions involved. You can make use of the diagonal scale. Now, what is mean by this comparative scale? When we are comparing the two things, especially you are having a destination, let us assume there is a destination, this is the A destination, this is B, or this is source A, this is destination B, and this is city Ludhiana, and this is city Chandigarh, let us assume. And there is a distance of 100 kilometers, let us assume, 100 kilometers. And a vehicle is taking 3 hours. Means we are comparing 2 dimensions, 100 kilometers and 3 hours. If you look at here, basically you can measure the speed here or you can correlate the speed. And if you are aware of the direction also, means from A to B, this becomes the velocity, this becomes a vector quantity. So for comparing the two quantity, distance and time, you can make use of the comparative scale. If you even if you are having a separate dimension, it is measured in distance is measured in a meter form or a centimeter form, and the time is measured in a hours form or maybe minutes or maybe second also. So it is decided accordingly. We will make use of the comparative scale even for comparing the 2 dimensions. You can make use of this comparative scale. Vernier scale. What is there? Everybody might have seen the vernier caliper. Vernier caliper. We might have seen the vernier caliper in our 10+2 class in the physics lab or maybe the other classes. Even in the workshop, you will find this vernier. For vernier caliper, we will find out one main scale division and one vernier scale division. And on the basis of that one, we calculate the least count. On the basis of that one, we calculate the least count. Here, whatever the principle which we have learned in a vernier caliper, same will be used for the vernier scale. ISO as the word indicates, equal. Metric means measurement. Metric means measurement. When we are measuring the dimensions, basically there are three dimensions: length, breadth, and height. Length, breadth, and height. Here, if you look at here, length is the breadth, this is height. Breadth and height are almost similar, but length is the bigger one. You might have seen the cube. Might have seen the object cube. I can draw it here. This is the cube object. Here, the length, breadth, and height are equal in nature. Means for that one, when we are going to measure the equal measurement, for that we will make use of the isometric scale. Equal measurement. Iso means equal, metric means measurement. And moreover, we will discuss this isometric scale in an isometric projection in detail in a subsequent class. Here I am just giving you the overview of that one. Scale of chord. Here if you look at here, in all the above five mentioned scales, plane scale, diagonal scale, comparative scale, vernier scale and isometric scale, we have measured only the linear measurement. Linear measurement. When we are talking in terms of the angular measurement, I can take one example related to that one. In angular measurement, we will make use of the scale of chord. I will show you one application related to that one. In detail, we will discuss in a subsequent classes. So here, this is basically a circular, this is the circle. And if you look at here, I take a point A. If you move in a anti-clockwise direction, and if you reaches at a point A again in anti-clockwise, will cover 360-degree angle. Clear? So this is the angular measurement. I take 2 points B and C on this circular part, and if I join it by a straight line, this straight line should not pass through the center of the circle. If it is passed through the center of the circle, then it is not a chord. Now this become a scale of chord. This become a scale of chord. For measuring this angle, will make use of the scale of chord, and moreover, here this angle will be measured in the form of the degree form. So basically, this represents your angular measurement by making use of the scale of chord which we have discussed here. If it is passage, if you look at here, these are the point D and E. If I join it with a straight line, now this becomes the diameter of the circle. Now this is not a, this is the basic difference between what is the BC and DE. BC is an arc, but it does not passes through the center of the circle. So this become a chord. And for the scale of chord, will make use of this one. So if it is passes through that one, it becomes, this angle is a 180 degree. If you look at here, this angle becomes, this is the half of the portion as we covered. So this becomes a 180 degree. So what we discuss, again I am for plane scale, diagonal scale, comparative scale, vernier scale, isometric scale, we are going to measure the linear measurement more or less. For scale of chord, we are going to measure the angular measurement. I have discussed started with the representative fraction or scale of factor, then we go to the length of the scale. Then after that, we discuss the different types of scale, and brief introduction about all the scales have been discussed here. If you have any question, you may ask me. Otherwise, we will discuss plane scale, diagonal scale, rest of the scale, comparative, vernier, isometric scale, and the scale of chord in a subsequent classes in detail. Thank you very much.